Number 24. How far from the nucleus in angstroms, and 1 angstrom equals 1 times 10 to the negative 10th meters, is the electron in a hydrogen atom if it has an energy of negative 8.72 times 10 to the negative 20th joules? Okay, so the question is asking how far from the nucleus. So let's draw a picture here, right? Let's draw a picture of a nucleus. So a nucleus is usually represented by a circle, right? And in this case, they told us that it was hydrogen. So I'll just put an H here. But now remember, electrons, where are electrons located? They're located outside the nucleus, in the electron cloud. So I'm going to draw a couple of them. So this would be n equals 1. If you guys are not familiar with the shells, we did plenty of practice before that goes into that. So if you want, you could go check out those questions. So we're just going to keep moving along here. So this would be n equals 1, n equals 2. And I just want to show you that this would be n equals 1 because it's the first shell off of the nucleus, right? And then this one would be n equals 2, which would be the second shell away from the nucleus. And they want to know how far from the nucleus. So it looks like if I took a point right in the middle of the nucleus, they want to know how far away. Well, it depends, right? It could be this far away if the electron was in the n equals 1 shell, right? If the electron was here. Or it could be even farther. It could be this far away, right? If the electron, which I'll put over here, was in the n equals 2 spot. So the question is, what n number is this electron located in? Right? Because the farther away, n equals 1, n equals 2, n equals 3, the distance is going to be longer, right? So the first thing we have to figure out is what shell is this electron located? Now let's see what they give us. They gave us an energy of negative 8.72 times 10 to the negative 20 joules. So that would be my En, negative 8.72 times 10 to the negative 20th joules. And they don't tell me the n. That's what I'm searching for. N equals question mark. And they tell me that it's a hydrogen atom. So remember, Bohr's model only follows hydrogen atoms. So I can use my equations that are listed with the Bohr model to figure this out. And the equation that I can use is En equals negative k z squared over n squared. Because I know the En, right? K, remember, is a constant number. It's the Rydberg constant. In this case, they tell you it's k, but nonetheless, k equals 2.179 times 10 to the negative 18th joules. So we could just plug that in. And we're solving for n. So that means that we must know z, right? And what does z represent? Z, I'll put it over here, z is the nuclear charge, aka the charge of the nucleus. And the charge of the nucleus comes from the atomic number. So the atomic number of hydrogen is 1, right? Atomic number. So that means that it has 1 proton. So the Z here would just be a plus 1. That would be the charge of the nucleus. So let's set it up. Negative 8.72 times 10 to the negative 20th equals negative, the K was 2.179 times 10 to the negative 18th times Z squared, so it would be a plus 1 squared, all over n squared. So what you can do here is you can crisscross, right? Because I have basically two ratios. This, the E, is technically over 1. So you can crisscross to get the n out of the denominator and into the numerator. So what you got here is negative 8.72 times 10 to the negative 20th n squared equals, if I did negative 2.179 times 10 to the negative 18th times 1 squared, it would just be negative 2.179 times 10 to the negative 18th. Get n by itself, you would have to divide by your energy number, negative 8.72 times 10 to the negative 20th on both sides, negative 8.72 times 10 to the negative 20th. That cancels out. N squared equals, calculate time, 2.179 times 10 to the negative 18th divided by 8.72 times 10 to the negative 20th. Negative divided by negative is a positive, so the answer will be positive. And I get roughly 25. Now I just have to take the square root because I want just n. And what's the square root of 25? It's just 5. So now I know that this electron is located in the 5th shell away from the nucleus, which means that I would have to draw 5 circles. I drew 1, 2, so technically I would have to draw 3 more if I wanted to draw that, but let's just pretend that it's there. You guys can draw that on your own paper, right? Just so that you guys can see. Okay, so now that electron is 5 shells away, but that doesn't answer the question. They want to know how far in angstroms. Well, there's another formula. Because we now know the n number, right? We now know that n equals 5. Now, another equation that goes along with the Bohr model has to do with the radius. And radius comes from the radius of a circle. And look what we drew here. Do you see how all that we're doing is we're finding a radius of a huge circle? So that's all that we're finding out. We have to find out the radius, and that's how far away the nucleus is. So the equation that we have to use is R equals n squared over z times a subnotch 0. Now, a is a constant number. So just like k, it's a constant number, it will never change. Just know that a sub 0 is always equal to 5.292 times 10 to the negative 11th. Let me make that a little bit. Negative 11th meters. This is called the Bohr radius. So you will be able to use this when you're talking about the Bohr model. So let's solve. R equals n squared. We now know that we're in the 5th shell, so it would be 5 squared all over z. And we already found out z from before, right? Z was the nuclear charge, and that was a +1. So it's divided by 1 times 5.292 times 10 to the negative 11th. And that will get your radius. Now just know that your radius will always be in terms of meters when you use this formula. So I'll put this over here. R equals 5 squared is 25, so 25 times 5.292 times 10 to the negative 11th. I'll round to 3 sig figs, so we have 1.32. 1.32 times 10 to the negative 9th, negative 9 meters. Okay, but they wanted the number in angstroms. But they give me a lovely conversion factor. 1 angstrom equals 1 times 10 to the negative 10th meters. So I'll just do the conversion up top here. 1.32 times 10 to the negative 9th meters times by that ratio. We don't want meters anymore. That goes on the bottom. We want angstrom. And the symbol for angstrom is that A with the little halo at the top. And it says that 1 angstrom, so 1 is 1 times 10 to the negative 10th meters, 1 times 10 to the negative 10th meters. Meters cancel out, and you're left with your answer. So 1.32 times 10 to the negative 9th divided by 1 times 10 to the negative 10th. You get 13.2 angstroms, and that's your final answer. So this one was a 2-part question. We first had to find out what shell it was located in, and then we could find out the actual distance from the nucleus, which was just secretly a radius. So hopefully this helped. Let me know in the comments what you think, and if you want to, click the subscribe button, you'll get tons more questions coming directly into your feed, and I think that would be great, right? So thank you for that. I'll see you guys all in the next question. Have a great day.